Alright folks, lesson number 14 here. A child rolls a marble bent on 100 centimeters long as shown in this figure. We use X to represent the position of the marble along the track. On the horizontal section from starting Alright. So on a horse, so it's 100 centimeters long. 100 centimeters long, and from X means from 0 meters to 20 seconds, she kicks the initial ball. So it's going to roll down at a constant velocity, and then it's going to pick up speed, and then it's going to travel at a constant velocity, and then as it goes up, it has going to be some initial speed. So of course it's going to go up, and then it's going to slow down to a negative, up to 0, and then it's going to come back down, and then it's going to go back to its original speed. So that's what this is. From horizontal section from 0 to 20 meters and 40 to 60, the marble rolls with a constant speed. On the sloping section, the speed of the marble changes steadily. At the places where the slope changes, the marble stays on the track and does not undergo sudden change in speed. Okay, whatever. The child gives the marble some initial speed at x equals 0 and t equals 0. Then watches it roll to 9 meters and where it turns around, eventually returning to 0 with the same speed as the child initially released it. So prepare the graph versus x versus t, b versus t, and a versus t on vertical line with their time axis identical to show the motion of the marble. You will not be able to place some numbers other than 0 on the horizontal axis on the velocity or acceleration axis, but shows like the correct relative sizes of the graphs. Anyways, so the child is going to roll the marble, and it's going to roll, and you can easily visualize this. So let's look at this. Oh, actually, there we go. So let's look at the position. Let's look at the velocity here. So I'm going to look at the velocity versus time. I know this is a little screwy, but I'm just going to pull up the solution manual. I know I just tried to fit this in here. So when the marble rolls, the velocity is going to be at some constant initial velocity. And then and also keep in mind, in the traditional sense, we're not going to call down positive or negative. We're going to call the direction that the marble faces positive, towards the right side of where the track is, and if it's going towards the left, that we're going to call that direction negative. So the direction can be positive here, positive here, positive here, positive there. So initially, this marble is going to roll at a constant velocity, and then it's going to speed up. This velocity is going to go a little higher, and then it's going to travel at a constant velocity. And notice from here, the velocity is going to slow down to the point where it stops, where the velocity is 0, and then it's going to travel at some in the opposite direction to the point where it's going to have some speed going in this direction, which is going to be a negative portion, and then it's going to slow down a little, so that's why it's going up. So as it's going up, it's going to slow down in the positive direction, and then it's going to go back to its original position. So notice that the acceleration here is going to be 0, some initial velocity where it slopes down, and then it's going to go 0, and then it's going to slow down to some constant acceleration. So it's somewhere in between here is where it's going to stop, and then it's going to go slow down to its 0, and then the acceleration here is going to be this value right here, some positive value, maybe I would say maybe a little less, but I don't know exactly. And then it's going to go back down to its original. And the position versus time graph, here you have a line. Notice that the constant velocity is a straight line that's going to go pick up speed as it goes along, and then here's going to be another line. I know this graph sucks, but this should be another line here. And then as the slope changes as the velocity changes going to 0, that's where it's going to stop. So this would be 90 centimeters right here, and it's going to go down to the point where it's going to travel at that constant velocity, and then it's going to slant a little sideways here. That's where the speed is going to be less and less, so it's going to go a little less, and then it's going to travel back to a line and return to its original position where the velocity is 0. So basically, folks, this is a good problem to ask. I really am a fan of this, because this is more of a conceptual question more than anything else. So don't think about memorizing how to solve this. More like think about what is physically happening. Remember that the change of velocity is just, or the acceleration by definition is the change of velocity over the time interval, and the definition of the change of the velocity is the change of position over the change of time. That's all this is.